So in today's session we will learn about the computer application in business, and this is for the program BCom and for the 5th semester, which comes under the Karnataka University Award, and the session number is 14th. Learning objectives of this session: users of DBMS, several types of users are associated with the DBMS that we are going to learn in this session. Along with that, relations in DBMS and schemas of DBMS. Outcomes: DBMS used by whom? So those who are the people who are using the DBMS that we are going to learn in this particular session. DBMS architecture or database architecture. Database management systems architecture will help us to understand the components of database system and the relationship among them. So basically it will tell us the architecture, how the internally structure of the database will be looks like. That we are going to study in this session. The types of architecture. In the types of architecture, it is further divided into three types. One is single tier, two tier and three tier. So that means single layer, two layer and three layer. Here tier means the layers. So in the single tier, in this type of architecture, the database is readily available on the client machine. That means, so the user want to use the database management system, that database management system DBMS is readily available on that particular machine. So any request made by the client doesn't require a network connection to perform the action on the database, because it is readily available on the client machine. That is why it is called as a single tier architecture. Then moving on to the two-tier architecture. In the two-tier architecture, it will be containing the two components. One is the client machine, another one is the server machine. In the client machine, it will contain the database user and the database management application, whereas in the server machine, it will contain the database system. So where the database, the client machine will request for some request through the database user. That will be done through by using the database application, and that request will be sent over the network to the server machine, where the server machine is containing the database system, and that request will be processed and given back to the client machine. And this type of architecture is called as a two-tier architecture. And the last one we come across, three-tier architecture. In the three-tier architecture, in the client machine, in the previous slide we seen that the client machine contains the database user as well as the client database application. Same, there is no changes, and there is a network connection in between them, and it is connected back to the server machine. In the server machine, there is a little modification. The server DBMS application is there, and then in turn it is connected to the database system. So here, whenever the client machine database user is going to make a request through the client DBMS application, that will be transferred through the network connection and connected back to the server machine, and in turn the server machine will be connected back to the DBMS application. Through DBMS application, server application, it will be connected back to the database system, where the request will be served, and whatever the request asked by the client will be served by the server machine. And this type of architecture is called as a three-tier architecture. Database management system three-level architecture or three-tier architecture. It contains, this diagram depicts the architecture of the database management system. Contains three levels. One is external level, another one is conceptual level, another one is internal level. In the external level, it will contain the views, external views, that is view 1, view 2, view 3 up to view n, and these can be utilized by users 1, user 2, user 3 up to user n. And in the conceptual level, it will be concerned about the internal, how actually the data will be stored. And in the last level, that is internal level, in what physical medium we are going to store the data in the database management system. That will be concerned about the internal level. So that is all about the three-level architecture. We will deal each levels one by one. First one, external level. It is also called as a view level. The reason this level is called as view is because several users can view their desired data from this level. For example, in an organization, some end user want to view the statistics of a company such as invoices, then that particular can able to view only the invoices and the same user want to view the production details, then the same user can able to view only the production details. So the same database can be viewed in differently by the different users. That is why it is called as a external level. The user doesn't need to know the database schema details such as data structure, table definition, etc. It doesn't need to worry about how the data is stored. User only concerned about data which is what returned back to the view level. It is concerned about what is going to ask and what it has came back to the user. That is all about the external level. Next one, the conceptual level. It is called as a logical level. The whole design of the database, such as the relationship among the data, schema of the data, etc., are described in this level. So in the conceptual level, actually how internally the database will be stored, and that will be described in this conceptual level. The database constraints and security are also implemented in this level. This level is maintained by one of the users, that is DBA. DBA means database administrators. Next we come across internal level. This level is also known as a physical level. This level describes how actually the data is stored on the physical devices such as hard disks, SSDs, storage devices. This level is also responsible for allocating the space to the data, and this is the lowest level of architecture where how actually the data will be stored on the physical media. Okay, so that is all about the internal level. Then we come across the data abstraction in DBMS. Data abstraction is nothing but it is a process of hiding the irrelevant details from the user, is called as a data abstraction. So that means it doesn't concerned about how actually the data is stored inside the database management system. It is actually concerned about what actually it is going to get. So view 1, view 2, view 3, and that will be viewed in the logical level, and it will be concerned about the physical level. It is concerned about getting the data, not about how actually it is stored. So that concept is called as a data abstraction. So in DBMS schema, definition of the schema, the design of database is called as a schema. So while designing the database, we come across the structure of the database, and that designing structure of the database is called as a schema. It is also called as a schema diagram. Schema types: physical schema, logical schema, and view schema. The design of a database at physical level is called as a physical schema, and how the data stored in blocks of storage is described at this level. And the design of database at the logical level is called as logical schema. The programmers and database administrators work at this level. The design of database at view level is called as view schema. This is generally describes the end user interactions and database systems. So that is all about the three schemas: physical, logical, and view schema. Definition of instance. The data stored in the database at that particular moment of time is called as an instance. For example, let us say we have a single table student in a database. Today the table has 100 records. So today the instance of the database is 100 records. So let us say we are going to add another 100 records in this table by tomorrow. So the instance of the database tomorrow will be having 200 records in the table. So data instance is nothing but what is the exact number of records which are present on that particular time will be called as a data instance. Users of database management system. The users of database management system are database administrators, native or end users, system analysts, database designers, application programmers, and sophisticated users. So these are all the different types of users that we come across. Database administrators are the users which are capable of managing and monitoring and granting and revoking the each and every aspects of the database will be maintained by the database administrators. End users are the those who are going to use the applications for their information, and system analysts are the people those who are associated with the system applications. We come across the last slide, that is MCQs, multiple choice questions. Number of tires in DBMS: 3 tire, 2 tire, 1 tire and all. As you know that the DBMS will be available in 1 tire, 2 tire and 3 tire. The answer will be D, all. Aiding of internal data is referred as abstraction, instance, none, isolation. So hiding the internal details of the data is called as abstraction. The answer will be option A. Third question. Users of DBMS are naive, database administrators, sophisticated and D, all. So all the three users are associated as DBMS users and the option will be D, all. Database schemas are physical, logical, view and D, all. So the database schemas are available in physical schema, logical schema and view schema. The option will be D, all. Database is designed in which view? External view, logical view, conceptual view and D, all. It is designed at P, logical view. Questions, 2 mark questions. Types of architecture: design, define data abstraction, define data instance. 5 mark questions. Explain briefly the architecture of DBMS, explain the schemas of DBMS. 10 mark questions. Explain briefly about the 3-tier architecture of DBMS, elaborate users of DBMS. The references, these are the references. If you want to need additional information, you can go and refer to these particular books, and also online sources which are available freely available in the online. Thank you.